My voice is audible. My voice is audible to you. Anybody, you can give me the reply. My voice is audible.
Yes, sir.
Okay. So in the last lecture, we have seen how to calculate the potential energy, formula of the potential energy mgh, then kinetic energy half mv square. Okay, so k is equal to half mv square. These things already you have studied. P is equal to potential energy is equal to mgh. This also known to you. Now further part we are going to see here, law of conservation of energy. Law of conservation of energy. This is also known to you. So here, energy, what is the law? Energy can neither be created nor destroyed. It can transfer from one form to another. Okay. So this is the law of conservation of energy. So energy can neither be created nor destroyed comma, it can transfer from one form to another. Okay, so form of the energy is getting changed, but you cannot create the energy and you cannot destroy the energy. Okay, so this is the law of conservation of energy. Now the new part is work energy principle. Now on this principle we are going to solve the numericals. This is the important principle, but it is very easy. Work energy principle. Okay, in the examination based on this work energy principle, the numericals may be asked. So here, work energy principle may be stated as work done by the system of forces acting on a body during displacement is equal to the change in kinetic energy of the body during the same displacement Okay, so in the simple words, if I say you what is the work energy principle, then it says that work done whatever the work done is equal to change in kinetic energy. Okay, work done is nothing but change in kinetic energy. This is the simple equation of the work energy principle. What is work energy principle? So work done is equal to change in kinetic energy. This above part, it is the standard definition, but the concept is, you can say that the work done is nothing but it is change in kinetic energy. So how do we calculate the work done? Work done is equal to F into S. Okay, summation F into S. We have already discussed about the work done. Now change in kinetic energy. So change in kinetic energy means final kinetic energy minus initial kinetic energy. So final kinetic energy is half mv square is the final kinetic energy. What is the initial kinetic energy? Initial kinetic energy is half mu square. Okay, so from final kinetic energy, if you minus initial kinetic energy, you will get change in kinetic energy. Okay, and that is equal to the work done. So now we will see work energy principle for a single block. So the work energy principle, work energy principle for single block. Now I will draw the diagram. Okay. So suppose now this is a surface. So on this surface, suppose this box is there. This is a box. Now on this box, force is applied. Suppose force is applied, F. Okay. Now the mass of the box is m, and the initial velocity is u. U is the initial velocity of the box. Okay. So when this force is applied, it will displace. It will displace. Suppose now from the displacement of the box is s. Okay. Suppose the displacement of the box, it is s. This is the displaced box. Okay. And after the displacement s, its velocity is, suppose its velocity is now v. Okay, initially its velocity is u. This box is having mass m. When you apply the force F, this box is displaced from this place, and when you apply the force, its velocity is also changed, and at the displacement s, suppose its velocity is v. Suppose its velocity is v. Now we want to write work energy principle for this block. We want to write work energy principle for this block. So first of all, I will write work done. What is the work done? Work done, W is equal to, what is the formula for work done? It is force into displacement. So summation F into S. This is the work done. Okay. What is the initial kinetic energy? Initial kinetic energy of the block. Initial kinetic energy, what is the initial velocity? U. So the initial kinetic energy will be half mu square. Half mu square. Then at this point here, what is the final kinetic energy? Final kinetic energy, you should consider final velocity. So it is half mv square. It is half mv square. Now this is the final kinetic energy, and this is the initial kinetic energy. So I can calculate change in kinetic energy. Okay. So change in kinetic energy K, it is equal to final kinetic energy half mv square minus initial kinetic energy half mu square. Okay, so if I rearrange this term, then it will be change in K, that is kinetic energy, half I will take common, m also I will take common because the box is a single box, mass is same. So in bracket, what will remain? It is v square minus u square. So it is half m v square minus u square. This is your change in kinetic energy. Okay. So now, according to work energy principle, according to work energy principle, work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy. So what is the work done? This is the work done here, summation F into S. So work done is summation F into S is equal to, what is change in kinetic energy? This one, half m v square minus u square. So this is the work energy principle for the single block. Okay, you don't need to remember this. कसं आलं तेवढं बघा, तेच आपल्याला करायचं आहे प्रॉब्लेम सॉल्व्ह करताना. ओके, just you remember that in the work energy principle, work done is equal to change in the kinetic energy. Okay. So this is for the single block. Now what will happen if I use the connected blocks? Now see, again this is the surface. Now here on this surface two blocks are there which are connected together. So now this is the first block and this is the second block. These two blocks are there and these two blocks are tied with a rope. Okay, so this is the rope. These two blocks are tied. Then let us say that the initial velocity of this first block is u1, the initial velocity of the second block is u2, the mass of this block is m1, mass of this block is m2. Okay. Now when you apply, suppose now if I apply the force on this block and this force is F, and what will happen now? These two blocks are connected blocks, so the displacement of the both the blocks is same. Displacement will be same. Now when I apply this force F, these two blocks are moved towards right hand side. Okay, these two blocks are moved towards this side. Suppose now this is the final position of the block. Now suppose this is the final position of the block. Okay, in this manner. Okay, so this is the final position of the block. Okay. So suppose now the final velocity, initial velocity of this m1 is u1. Now the final velocity is v1. Mass will remain as it is, m1, m2, and here the velocity is v2, and the string is as it is. The string which by which means they are attached to each other. This rope is as it is. Okay. Now the displacement, if I show here, the displacement. So this block of mass m2, the displacement is this one. This is the displacement s. Okay, and ही displacement जेवढी असणार आहे तेवढीच displacement कोणाची असणार आहे m1. Now if I see here m1, the displacement of m1 will be this much, and this displacement is also s, because these two blocks are connected blocks. म्हणजे मूव झाले तर दोघे एक साथच मूव होणार आहे. Okay, and they are tied with a rope, or you can say with a bar, so that the distance between them will remain constant. म्हणजे दोन ब्लॉक असे ते असेच पुढे मूव होणार आहे. Okay, so whatever the displacement of this mass first block m2, same displacement will be same is the displacement of that block m1. So the displacement is same over here. Now for this, if I apply the work energy principle, what does the work energy principle says? Work done is equal to change in kinetic energy, work done. So here, if I calculate the work done, what is the work done? You know the formula for the work done. What is work done? It is summation F into S. Force into displacement is the work done. Okay, in summation F, all we will take into the consideration the forces which causes the displacement. So all the forces which causes the displacement and the displacement S, whatever the displacement is there. So this is the work done, which is equal to, now here work done is equal to change in kinetic energy. Now here two blocks are there. So we should take the change in kinetic energy of block 1 and then change in kinetic energy of block 2. So for the first block of this M1, what is the change in kinetic energy? So it is final kinetic energy, half M1 V1 square minus half M1 U1 square. This is the change in kinetic energy for the first block, this M1 block. Okay. Now for this M2, so plus for this M2 block, it is half M2 V2 square minus half M2 U2 square. Okay, so this is the work energy principle for this block also. Two blocks, when the two blocks are there. For three blocks are there, here plus third term will be there, half M3 V3 square minus U3 square. If four blocks are there, half M4 V4 square minus U4 square. If n number of blocks are there, half Mn Vn square minus Un square. Okay, that much of terms you need to add. जसं आपण मोमेंट ऑफ इनर्शिया मध्ये करत होतो बघा, एक फिगर असली की पॅरलल ऍक्सिस थेरम वापरताना एक ब्रॅकेट, दुसरी अजून फिगर असली की प्लस दुसरा ब्रॅकेट येणार, तिसरी फिगर असली की तिसरी टर्म येणार. तसं इथं जेवढे ब्लॉक्स असतील ना तेवढ्या तुमच्या टर्म्स येणार चेंज इन कायनेटिक एनर्जी मध्ये. ओके, so here if I rearrange this formula, then it will be summation f into s is equal to, if I take half m1 common from this term, half m1, what will remain in the bracket? It is v1 square minus u1 square. Okay, and plus here it is, if I take half m2 common, then what will remain here? It is v2 square minus u2 square. So this is your work energy principle for the two blocks if double block is there. Okay. This is for single block. This is the work energy principle for the single block. You can see here there is only a single term. But when the same principle is used for the two blocks, then there will be two terms. हे पहिल्या ब्लॉक साठी आणि ही दुसऱ्या ब्लॉक साठी. ओके, इज इट अंडरस्टूड? व्हाट इज वर्क एनर्जी प्रिंसिपल? Yes, no?
Yes, sir.
Okay, so now we will see the numericals on this work energy principle. So take the problem. A body is weighing 300 Newton, is pushed up 30 degree, is pushed up on 30 degree is pushed up on 30 degree inclined plane by a force of 400 Newton, acting parallel to the plane, if the initial velocity of the body is 1.5 meter per second, 1.5 meter per second, comma, the coefficient of friction is 0.2, then what velocity the body will attain body will attain after moving 6 meter. After moving 6 meter, use work energy principle. Okay, so body weighing 300 Newton is pushed up on a 30-degree inclined plane by a force of 400 Newton. So if I draw the diagram, now see, this is 30-degree inclined plane. This plane is inclined at an angle of 30 degree. Then here a body weighing 300 Newton. Suppose now this is a body which is having a weight of 300 Newton. Here is the centroid of the body. So weight is acting vertically downwards. Always weight is acting vertically downwards. So this is the weight which is acting vertically downwards, 300 Newton. Then it is pulled up. Oh, sorry, pushed up. So pushed up means which is the direction of motion? Pushed up means this is the upward direction. So pushed up, this is the direction of the motion. Okay, it is pushed up by a force of 400 Newton acting parallel to the plane. Now this is our plane. So the force is parallel to the plane. So this force F, if I draw the force F, this force F, okay, this is parallel to this plane. So this is the force F. Now not it is F, 400 Newton. Value is given to us. 400 Newton force. Okay. What is the initial velocity? The initial velocity of the body is 1.5 meter per second. So here the initial velocity is also given to us. So the initial velocity U is equal to 1.5 meter per second. What is the coefficient of friction? Mu. Mu is 0.2. So here I can write mu is equal to 0.2. This is the coefficient of friction. Okay. So what velocity the body will attain after moving 6 meter? So when the body is displaced for the 6 meter from this point. So from this point, if the body moves up to a distance of 6 meter, okay. So this is the 6 meter, and here somewhere the new position will be there. Okay. Here is the new position of the body. आता हे प्लेनच असणार आहे, हा प्लेन आहे. Here somewhere 6 मीटर. सर या 6 मीटर तिची डिस्प्लेसमेंट झाल्यानंतर काय म्हटलेले त्यांनी, ह्याची वेलॉसिटी किती असेल? व्हॉट इज द वेलॉसिटी ऑफ द बॉडी? यूज वर्क एनर्जी प्रिन्सिपल. यूज वर्क एनर्जी प्रिन्सिपल. Now if you resolve the force first, if I resolve this 300 Newton force, then this is one component which is perpendicular to the inclined plane, and the another component which will be parallel to this inclined plane. Okay, so now here this is our x-axis. Now this inclined plane is our x-axis, and this plane perpendicular to this is our y-axis. Now this plane is our y-axis, and here this plane, this is our x-axis. Okay, so now when you resolve this angle is 30 degree, then you know that angle between the lines is angle between their tangents or normals. This angle is also 30 degree. This will be 300 cos 30. This is 300 sin 30. Now here normal reaction is also there. So this is the normal reaction R. This is the normal reaction R. And also the frictional force will be there, which is opposite to the motion. Now motion is in this rightward side, so the frictional force will be in this side. So this is our frictional force F, which can be calculated as mu into R. Mu into R. So first of all, what we will do, we will calculate this R. Okay. Now this inclined plane is our x-axis, and perpendicular to this angle is 90. Yeah? This is our y-axis. So these we should consider in summation Fy. So when I apply summation Fy equal to 0, this y-axis parallel to this y-axis R is there, and this 30 cos 30 is there. So it is R minus 300 cos 30 is equal to 0. Therefore, R is equal to 300 cos 30. Therefore, R is equal to, what is the value? It is 259.8 Newton. This is the value of R. Check the calculation. Okay. Okay. So here now, after calculating the R, calculate the frictional force. So frictional force F is equal to, it is mu, F is equal to, it is mu into R, which is equal to mu is 0.2, it is given, into R. R is the normal reaction and it is 259.80. Therefore, F is equal to frictional force. Do the calculation, 0.2 into 259.8, it is 51.96 Newton. Okay. Now we know the value of this F now. F is 51.96 kilonewton. This is the frictional force. Now we will apply work energy principle to calculate the velocity. Now see how we will apply the work energy principle. So the work energy principle says that work done is equal to change in kinetic energy. This work energy principle says that. So here work done is nothing but it is summation F into S, which is equal to. Now change in kinetic energy, single block is there. So for the single block, change in kinetic energy is half m v square minus u square. So now summation F. So now F into S. Now we want to calculate the work done. So the forces which are in the direction of the displacement, those we considered as positive. The forces which are in the opposite direction of the displacement, those we considered as negative. Now here see, this is the direction of the motion. So this is the direction of the displacement also. Okay, so displacement is in the horizontal direction, is in the x direction. So we should consider the forces in x direction only. If the displacement is in the y direction, then we should consider the forces in y direction. Now here in this case, displacement is in the x direction. So consider these horizontal forces only, that is this parallel to our x axis. So now first of all, this force 400 Newton. This 400 Newton force is in the direction of the displacement. So it is positive. So here first of all I will write 400 positive. Then this force 300 sine 30. So this 300 sine 30 is in the opposite direction to that of displacement. Displacement या बाजूला आहे आणि force इकडच्या बाजूला आहे. So this force we should take it as a negative. So it is 3 minus 300 sine 30. Okay. Then again you can see this frictional force is also there. Now this frictional force is also in the opposite direction to that of the displacement. So this frictional force also we should take it as a minus. But what is the value of that? 51.96. So it is minus 51.96. फोर्सेस सगळे संपले का बघा. डिस्प्लेसमेंट कशी आहे, हॉरिझॉन्टल आहे, म्हणजे या एक्स ऍक्सिस वरती डिस्प्लेसमेंट आहे आपली. तर ह्याला पॅरलल सगळे फोर्सेस घेतले का एकदा चेक करायचं. हा फोर्स पॅरलल आहे का, घेतलाय का कन्सिडरेशन मध्ये, घेतलाय. हा फोर्स घेतलाय का, घेतलेला आहे. हा फोर्स पण आहे, घेतलाय का, घेतलाय. हे तीन सोडून कोण आहेत का अजून, आर येणार नाही. 300 cos 30 येणार नाही, कारण हे दोन कुणाला पॅरलल आहेत, वाय ला. आणि आपली डिस्प्लेसमेंट वाय डायरेक्शनला झालेली नाहीये. आपली डिस्प्लेसमेंट कुठल्या डायरेक्शनला झालेली आहे, एक्स डायरेक्शनला. म्हणून हे एक्स मधले सगळे फोर्सेस आपण घ्यायचे कॅल्क्युलेशनला इथं. ओके. सो विच इज इक्वल टू हाफ इंटू एम. सो नाउ व्हाट इज द वैल्यू ऑफ एम. सो हियर यू कैन सी द वेट ऑफ द बॉडी इज 300. Weight of the body is 300. Now what is the value of m then? See here I will do. What is the weight of the body? W is equal to 300 Newton. So therefore m, mass is equal to what? It is W upon G. W is equal to m into G is the formula. So here m is equal to, it is 300 divided by 9.81. So what is the mass? It is 30.58 kg, right? This is the mass. Okay, you can do this calculation on below this also. त्याच्या खाली सुद्धा किंवा इकडे साइडला सुद्धा करू शकता तुम्ही. Okay. So this is the value of mass. We know the weight. Mass is always in kg. Weight is always in Newton. So here 30.58 kg. So I will write here 30.58 is m into v square is final velocity. We don't know that, we need to calculate the value. V square final velocity, we will keep it as it is, and initial velocity is 1.5. So minus 1.5 square. So here in this equation, the only unknown is the velocity. If you solve this, you will get the value of v velocity. Let me know the value.
सर 30.58 कुठून आलं?
हे मास आहे ना, हे काय इथं दाखवलं की सगळं कॅल्क्युलेशन. दिस इज वेट 300 न्यूटन, इट्स युनिट इज न्यूटन. न्यूटन मध्ये नेहमी आपण काय मोजतो? फोर्स और इट इज वेट. Okay, so weight is 300 Newton. Here in the formula we required mass. M means mass. So mass is always measured in kg. So I have told you in the first lecture 1 kg is equal to 9.81 Newton. तुम्ही absent होता का पहिल्या लेक्चरला?
नाही सर, आलं ध्यान.
आठवलं का? मग इथे W equal to 300 Newton. मास म्हणजे काय येणार? W divided by G. So it is 300 divided by 9.81. So this is the value of mass. Mass is always in kg. लक्षात ठेवा. M हे मास आहे. मास कधीही kg मध्येच पाहिजे. आणि W म्हणजे वेट आहे. वेट हे नेहमी न्यूटन मध्ये पाहिजे. न्यूटन और किलो न्यूटन. मास इज ऑलवेज इन ग्रॅम और किलोग्रॅम. आणि हे त्यांच्यामधलं कन्वर्जन आहे. 1 kg is equal to 9.81 न्यूटन. हे लक्षात ठेवा नेहमी.
Yes, sir.
So after finding out, when you solve this, you will get the velocity as 8.94 meter per second. This is the final answer. This is the final answer. Okay, समझला का problem? These types of problems are there. These types of problems they will ask in the examination. Is it clear now how to solve this? Any doubt?
No, sir.
Okay, so we will take the next numerical then if you don't have any doubt. The next numerical is determine the constant force. Determine the constant force P that will give the system of body shown in figure of velocity of 3 meter per second 3 meter per second after moving 4.5 meter from rest. Full stop. The coefficient of friction between block and plane is 0.3. Full stop. Assume pulleys are smooth. I will draw the diagram, but you understand the problem. Determine the constant force P. So force P is acting over there, and that value of force P we need to find out for the given system of forces. In a figure, a velocity of 3 meter per second. Okay. So what is its velocity? 3 meter per second after moving 4.5 meter from rest. So from rest means initially when the distance is 0 meter, the initial velocity is also 0 at rest. Okay. So it will attain a velocity of 3 meter per second. So its final velocity V is 3 meter per second when S is equal to 4.5 meter. After moving S, what is the S? 4.5 meter. Okay. So here from this, if I write the given data, then given data will be the value of mu is given. Mu is 0.3. Okay. Value of mu is given. Mu is 0.3. Initial velocity U is equal to 0 meter per second. Final velocity V is equal to 3 meter per second. And then S displacement is 4.5 meter. This I came to know from these three lines. Okay. Now the remaining things they have given in the diagram. So now I will draw the diagram. So the diagram will be this is the diagram. Okay. This is the block. And second block is kept over here. And one more block, third block is there, which is at this place. So three blocks are kept. Here, pulleys are also there. So on these pulleys, the strings is passed. So these are the pulleys. Okay, so this is the pulley. Otherwise, I will draw it as it is. These are the pulleys. And the string is passed over these pulleys. It is like this. So the string is passed. The string is passed over the pulley. It is like this. And now here the external force F, that is P, sorry, external force is P, which is acting over P. Then the weight of each block is given. So through the CG of the block, the weight is acting. Weight is given in the diagram only. So weight of this block, it is 250 Newton. Then the weight of this second block, it is vertically acting vertically downwards like this. this weight will act like this. So here this weight is 1000 Newton, and here for the third block it is 500 Newton. 500 Newton. And in the problem they have told us that determine the constant value of force P, okay, for the given system. So now this is the force P for the given system. So this will try to move up the body. So here for this block, what is the direction of motion now for each and every block? So now when I consider this block 1, this is the direction of motion. Okay. For this block 2, this is the direction of the motion. For this block 3, this will be the direction of the motion. This is the direction of motion. Here this is also the direction of motion. Direction of motion for the third block. Okay. So now see this first block, and I will give the name. This is block number 1, this is 2, and this is block number 3. So first block and third block, they are resting on a horizontal surface, plain horizontal surface, and second block is rest on the inclined surface. Second block is rest on the inclined surface, and this inclination, they have given this inclination as vertical to horizontal ratio. This ratio they have given like this, vertical to horizontal. This is 4 and this is 3. So now from this 4 and 3, you can calculate this angle theta, and from that you can calculate what is the slope over here, because these two are the corresponding angles. Okay, corresponding angles. Then I will show the normal reaction in the diagram. So here the normal reaction is like this, R1. For this now normal reaction will be like this, R2, and for this also it is perpendicular. These are the normal reactions. This is R1, this reaction is R2, here is the reaction R3. Now if I show the frictional forces, frictional force will be, if this is the direction of the motion, frictional force will be in opposite direction for this block. Here also if this is the direction of the motion, then the frictional force will be in the opposite direction. This is the frictional force. Okay. F2, I will call this as F2. And third one, if this is moving upward, then the direction of frictional force is like this, F3. So this is F3. Okay. Obviously, if you have not taken the direction in the prescribed manner, means what is given in the, see, I have got one question that the block ची direction change असेल तर आन्सर चेंज होतं का? ऑब्वियसली चेंज होणार. ओके, ज्या डायरेक्शनला ब्लॉक मूव्ह होतोय त्याच्या अपोजिट डायरेक्शनलाच तुमचा फ्रिक्शनल फोर्स येणार आहे. तुम्ही जर दुसऱ्या कुठल्याही डायरेक्शनला जर ब्लॉक मूव्ह केला तर तुमच्या फ्रिक्शनल फोर्सची डायरेक्शन बदलणार. फ्रिक्शनल फोर्सची डायरेक्शन बदलली की प्लस मायनस बदलणार, प्लस मायनस बदलली की तुमचा आन्सर चेंज होणार. ओके, सो दॅट इज वाय पी फोर्स दिलेला इथं डायग्राम मध्ये, पी फोर्स दिलेला इथं. तर फोर्स जर या डायरेक्शनला असेल तर कॉमन सेन्स काय सांगते की या डायरेक्शनला फोर्स आहे म्हटल्यावर हा ब्लॉक पुढे ओढला जाईल. हा जर ब्लॉक पुढे ओढला गेला तर हा पण ब्लॉक या साईडला जाईल आणि हा पण ब्लॉक या साईडला ओढला जाईल. का? तर तिघ हे दोरीने कनेक्टेड आहेत. ऑल दीज ब्लॉक्स आर कनेक्टेड बाय द स्ट्रिंग. एक मिनिट. Okay, so now moving further, see, now this is the free body diagram. So in this case now, see, this is the horizontal plane, summation fx fy ला काय आपल्याला अडचण नाही, हाच आपला x axis आहे. हा पण हॉरिझॉन्टल प्लेन आहे, तर समेशन एफ एक्स आणि एफ वाय ला इथं पण आपल्याला अडचण नाही. एक्स म्हणजे हा आपला हॉरिझॉन्टल ऍक्सिस, वाय म्हणजे आपला नेहमीचा परपेंडिक्युलर ऍक्सिस. इथं एक्स आणि वाय ऍक्सिस तुमचे आपले नेहमीचे ऍक्सिस असणार आहेत असे, हा एक्स ऍक्सिस हा वाय ऍक्सिस. इथं पण बघा हा नेहमीचा आपला वाय ऍक्सिस, जसं आपण समेशन एफ एक्स एफ वाय करतो एक्स ऍक्सिस. पण इथं या फिगर मध्ये काय होईल, तुमचा जो एक्स ऍक्सिस आहे तो असा आहे. सो दिस इज द डायरेक्शन ऑफ युअर एक्स ऍक्सिस एक्स, आणि ह्याला परपेंडिक्युलर वाय असा येईल तुमचा एक्स आणि वाय. ओके, हे तुमच्या अंडरस्टँडिंग साठी मी ड्रॉ केलेले. मग आता इथं बघा हा जो फोर्स आहे 1000 न्यूटन. नाउ दिस इन्क्लाइंड प्लेन इज अवर एक्स ऍक्सिस, सो वी हॅव टू रिझॉल्व दिस फोर्स अकॉर्डिंग टू अवर प्लेन. So if I resolve this, then I will get one component perpendicular to this plane and another component is parallel to this plane. So it is on this line. So if what is this angle? This angle we need to calculate. So if I use tan of theta, this angle is theta. So it is opposite side upon, if this angle is 90 degree, this is opposite side upon adjacent side. So tan of theta is equal to 4/3. So theta is equal to, what is the value? It is 53.13 degree. So this angle is 53.13 degree. So this angle is also same, because angle between the lines is angle between their normals. So your this component will become 1000 cos of 53.15 degree, and this component become 1000 sin of 53.13 degree. Okay, dark close correct. Okay, so these are the components of this force of 1000 Newton. Now everything is there. Now we will calculate the value of these frictional forces. So this is our frictional force F1. Now we will calculate the value of F1, F2 and F3. So to avoid the confusion, extra diagrams I will rub down. Now you know what are our axes. First of all, we will calculate R1, R2, R3 and then F1, F2, F3. So for easy understanding, what I will do, I will make here table. So for your understanding, I am doing like this. Okay. बघा इथं मी घेणार आहे फर्स्ट ब्लॉक, इथं घेणार सेकंड ब्लॉक, इथं घेणार थर्ड ब्लॉक. So in this case, now what I am going to do, first of all, for first block, if I apply summation Fy equal to 0, here if I apply summation Fy equal to 0, what do I will get? R1 minus 250 equal to 0. R1 minus 250 equal to 0. Therefore, what is the value of R1? It is 250 Newton. Correct? Now we can calculate F1. Now what is the value of F1 is equal to mu into R. The common value of mu is already given. Here you know that mu is 0.3 for the surface. So it will be F1 is equal to, it is 0.3 into R1. R1 is 250. So the value of F1 is equal to, it is 75 Newton. This is the value of F1. Similarly for block 2 now. Now this is for the second block. I will rub this also, first, second, third. Now you know that who is first, who is second, who is third. Serially 1, 2 and 3. So the second block. Now if I apply summation Fy equal to 0 here. Summation Fy equal to 0 for second block. Now this is our inclined plane is x-axis and perpendicular to this is our y-axis. So these are the forces we should consider along the y-axis. So it will be R2 minus 1000 cos of 53.13 is equal to 0. Is equal to 0. Here what I will do, I will extend this, because 53.13 is equal to 0. Therefore R2 is equal to, what is the value of R2 then? R2 is equal to 600 Newton. F2 is equal to again mu into R2. Okay, here it is R1, here it is now R2. So F2 is equal to, it is 0.3 into 600. So F2 is equal to, what is the value? It is 180 Newton. 180 Newton. And for the third block, for this third block, now if I apply summation Fy equal to 0, I will get R3, which is upward, minus 500 is equal to 0. Therefore, R3 is equal to how much it is? 500. Now, if I use calculate the frictional force, F3 is equal to mu into R3. So, F3 is equal to mu is 0.3 into R3. This reaction, R3, what is the value? It is 500. So, F3 is equal to, what is the value of F3? It is 150 Newton. So, these are the values of R1, R2, R3 and F1, F2, F3. This is the value of R1. Here is the value of R2. Here is the value of R3. This is F1. This is the value of F2. This is the value of F3 for all the three blocks. Okay. Now we will apply work energy principle. Now work energy principle. There are three blocks are there. So here I will write work done. Here I will write work done, that is summation F into S is nothing but work done. Summation F into S is nothing but W, work done, is equal to change in kinetic energy. So change in kinetic energy, how many blocks are there? In previous problem, one block is there. Now 1, 2 and 3 blocks are there. So how many terms will come in the equation? If 3 blocks are there, then 3 terms. जेवढे block तेवढे term येणार. So for the first block, it is half m v1 square minus u1 square. हे कोणासाठी झालं? पहिल्या ब्लॉक साठी झालं. Plus half, here the mass is also m1, then half m2, it is v2 square minus u2 square, plus half third block साठी काय येणार? m3 v3 square minus u3 square. This is your work energy principle. Work done is equal to change in kinetic energy. मग ही झाली change in kinetic energy of first block. This is the change in kinetic energy of second block, and this is the change in kinetic energy of third block. And for nth block, you will write here n. Okay. So how many block? किती block साठी तुम्ही करू शकता? Now after this, we need to put the values. Okay. So here you can see. What is u? U is 0. It is start from the rest. So all these are start from the rest. All these blocks are start from the rest. So I can write here u1, which is equal to u2, which is equal to u3. This is nothing but u, which is start from the rest. It is 0 meter per second. 0 meter per second. Okay. So we need to determine the value of this force P when the final velocity is 3 meter per second. Final velocity किती? 3 meter per second. So I can write here for all the blocks. ह्याची पण final velocity 3 आहे, ह्याची पण 3 आहे, ह्याची पण 3 आहे. So I can write v1 is equal to v2 is equal to v3, which is equal to v, which is 3 meter per second. Now what is remaining? m1, m2 and m3 masses are remaining. So m1 is the mass of the first block. What is the weight of the first block? 250 Newton. It is 250 divided by 9.81. What is the value of m1 then? It is 25.48 kg. Please check all the values. M2 is this second block. What is the weight of this second block? 1000 Newton. So it is 1000 divided by 9.81. Which is equal to, so 1000 divided by 9.81, it is 101.93 kg. And m3 is equal to, it is 500 Newton. This is weight. So 500 divided by 9.81. Masses are always in kilograms or grams. So it is 50.96. This is 50.9. Now put all these values here in the equation. What is this displacement S? So S is given as 4.5 meters. S is given as 4.5 meters. Okay. इथपर्यंत झालं का लिहून?
Yes, sir.
म्हणजे ह्याच्या खालीच मी सोडवणार आहे प्रॉब्लेम, म्हणजे तुम्हाला लक्षात येईल कशाची व्हॅल्यू कुठे ठेवली आहे म्हणून विचारतोय. हे मी इरेज करणार आहे. झालंय का सगळ्यांचं? I have only got the confirmation from one student. Majority काय? Is it over? Whatever there on the board, have you taken down in your notebook?
Yes, sir.
Okay. So now we have written over here what is the initial value. It is 0 initial velocity. Final velocities of all the block. Initial velocity of all the block is 0. Final velocity of all the block is 3. The displacement of all the block is 4 because all these blocks are connected blocks. So 4.5. Masses we have just now calculated. Now put the values. Now here, summation F. See, we are applying this work energy principle to all the blocks. We have considered all the blocks. So we have to take the forces here in all the body. So now summation F, displacement. बघा आता मोशन या बाजूला आहे, म्हणजे तुमची डिस्प्लेसमेंट पण या बाजूलाच असणार आहे. ओके, ज्या डायरेक्शनला मोशन आहे त्याच डायरेक्शनला डिस्प्लेसमेंट असणार आहे. डिस्प्लेसमेंटच्या डायरेक्शनला जे फोर्सेस असतील त्यांना आपण काय घेणार? प्लस. आणि डिस्प्लेसमेंटच्या अपोजिट डायरेक्शनला जे फोर्सेस असतील त्यांना घेणार मायनस. आता हा ब्लॉक, या ब्लॉकची डिस्प्लेसमेंट लेफ्ट साइडला आहे आणि हा ब्लॉक हॉरिझॉन्टल इथं रेस्ट आहे, त्यामुळे डिस्प्लेसमेंट पण हॉरिझॉन्टल आहे. त्यामुळे हॉरिझॉन्टल फोर्सेस घ्यायची. इथं हॉरिझॉन्टल फोर्स कोणता आहे? पी. ओनली पी इज द अननोन हॉरिझॉन्टल फोर्स. सो दॅट पी आय विल कन्सिडर ओव्हर हियर, मायनस पी. This minus p. Then for this block now, here for this block, it is only this force. This is 1000 sin. आता या ब्लॉक साठी इन्क्लाइन प्लेन आहे हा, म्हणजे हा इन्क्लाइन प्लेन तुमचा एक्स ऍक्सिस झाला, हॉरिझॉन्टल ऍक्सिस. सो इथं कुठला फोर्स आहे? 1000 sin 53.13. But the motion is in upward direction and force is going in the opposite direction. So it is again minus 100 sin of 53.13 degree. Okay, 100 sin of 53.13 degree. Then again here for this third block, this is the force, frictional force. Here also we should take the frictional force for the first and second block. Now there is no any force here, acting force on this block. Okay, again the frictional forces are there which are in the opposite to the direction of motion. So minus for the first block f1 is 75. Again minus for the second block, f2 is 180. Again minus for the third block, f3 is 150. So these all are the forces. Multiply by the s is the displacement, it is 4.5, which is equal to, for the first it is half, for the first block half into m1 किती काढलं होतं आपण?
25.48.
25.48 into v2 square, v2 is 3, v2 square minus u2 square, u2 is 0. This is the first term. Okay, then plus, what is the second term? This is the second term, half m2 was 101.93 into, it is final velocity square minus initial velocity square. And then third plus half into m3 is 50.96 into final velocity square minus initial velocity square. Okay, so in this equation the only unknown is p. In this whole equation the only unknown is p. This p is the only unknown. So if you solve this, at the last you will get the answer. P is equal to 1383.36 Newton. Please verify the answer. Okay, verify the answer. So these types of problems, only these two types of problems will be asked in the examination. Either they will give you a single block. बघा इथं सिंगल ब्लॉक जर दिला असेल, सिंगल ब्लॉक, तर त्याला असं सोडवायचं. एकच ब्लॉक येणार, वर्क एनर्जी प्रिन्सिपल वापरल्यावरती बघा F × S = एकच टर्म येणार. एकच टर्म काय येणार? एकच ब्लॉक आहे. जर दोन ब्लॉक असतील तर दोन टर्म येणार फक्त. इथं दोनच ब्लॉक जर असतील तर इथं फक्त दोन टर्म येणार. आणि जर तीन ब्लॉक असतील तर इथे किती टर्म येणार? तीन टर्म येणार. चार ब्लॉक दिले असतील तर चार येणार. पण एवढं 3 आणि 4 एक्झामला देत नाहीत. हा सुद्धा प्रॉब्लेम लेंदी आहे. एक्झामला 3 ब्लॉक देत नाहीत. मॅक्झिमम 1 or 2 ब्लॉक. ओके, सो व्हाय आय हॅव टेकन द न्यूमेरिकल ऑफ थर्ड ब्लॉक, so that you will be familiar with the 3 blocks. Then what will happen in the examination? If you get a single block or double block, you can easily solve. Okay, now have you understood this, what to do in these types of problems? There is only just one formula, summation F × S is equal to change in kinetic energy. Change in kinetic energy means what? Final kinetic energy minus initial kinetic energy. तेच केलेलं आहे आपण इथं. ओके, आणि जेवढे ब्लॉक्स असतील तेवढ्या काय येणार आहे तिथं? टर्म्स येणार आहेत. एवढं लक्षात ठेवा. इज इट क्लिअर नाउ?
Yes, sir.
Okay, so now we will move forward for the next bit. Okay, now we will move forward for the next bit. Before going to the next bit, if in the same problem, if they told you to calculate the tension in this string, okay, या स्ट्रिंग मधलं टेन्शन काढा म्हणून सांगितलं असतं बघा, मी इथं हायलाइट करतो त्याला. या स्ट्रिंग मधलं टेन्शन किती आहे, T1 = हाऊ मच, हे जर तुम्हाला विचारलं असतं, आता प्रॉब्लेम मध्ये विचारलेलं नाहीये, पण विचारलं असतं तर काय केलं असतं? What you will do if they ask you? It is very simple. आता स्ट्रिंग मधले फोर्सेस आपण का घेतले नाहीत? कारण की आपण सेपरेट, जोपर्यंत सेपरेट फ्री बॉडी डायग्राम घेऊन ह्याला कट करत नाही डायग्राम, फक्त आता ब्लॉकची घेत नाही, तोपर्यंत त्यामधला फोर्स आपण दाखवत नाही. जसं आपण ट्रसला करतो, जोपर्यंत सेक्शन लाईन ही ट्रसच्या मेंबरला कट होत नाही, कट जर झाली सेक्शन लाईन तरच आपण मेंबर मधला फोर्स घेतो. जर सेक्शन लाईन कट होत नसेल तर आपण त्या मेंबर मधला फोर्स घेत नाही कॅल्क्युलेशन करताना. कुठं? मेथड ऑफ सेक्शन मध्ये, ट्रसला. सेम वे हिअर, इथं आपण फक्त जर पहिल्या ब्लॉकची फ्री बॉडी डायग्राम जर कन्सिडर केली असती तर इथनं दोरी आपण कट करून घेतली असती ना, ही फर्स्ट ब्लॉक साठीची. दुसऱ्या ब्लॉकची घेतली असती तर ह्या दोन स्ट्रिंग आल्या असत्या. तिसऱ्या ब्लॉकची फ्री बॉडी डायग्राम घेतली असती तर ही एक स्ट्रिंग आली असती. पण जर तुम्ही पूर्ण बॉडी एकदाच घेताय तर या स्ट्रिंगला कुठं कट करताय का? तुम्ही करत नाही. म्हणून पूर्ण बॉडीचं जेव्हा हे इक्वेशन आपण वापरलं तेव्हा इथं टी ची टर्म्स कुठंच आली नाही बघा. टेन्शन इन द स्ट्रिंग कुठंच आलं नाही. का? तर ही पूर्ण होल बॉडीला आपण वापरत होतो. इथं स्ट्रिंग कुठं कट झालेली नाही. पण जर तुम्हाला एक्झाम मध्ये म्हटलं की हा T1 मधला फोर्स काढा, तर तुम्हाला काय करावं लागेल? तुम्हाला त्या केसमध्ये ही एवढी फ्री बॉडी डायग्राम कन्सिडर करावी लागेल. यू नीड टू कन्सिडर दिस मच ऑफ फ्री बॉडी डायग्राम. This much of free body diagram. Okay, to calculate the T1, this much of free body diagram you need to consider. So if you take the section like this much of free body diagram, then the string is cutting down and then you can show the tensile force in the string. Okay, कसं करायचं सांगू का? तर तुम्ही सॉल्व करताय स्ट्रिंग मधला फोर्स हे प्रिन्सिपल वापरून, or shall I tell you how to solve? बोला पटकन. मी विचारलं हे तुम्ही टेन्शन T1 ची व्हॅल्यू स्वतः हे प्रिन्सिपल वापरून कॅल्क्युलेट करू शकताय का? का मी सॉल्व करून देऊ कसं काढायचं T1 ते? काय म्हणताय? हा, काय म्हणताय? परत एकदा सांगा. क्वेश्चन कळला का नाही? काय विचारतोय? मराठीत विचारतोय की सांगा लवकर पटकन. वेळ कशाला घालवताय? नसले तर सांगा, मी तुम्हाला करून दाखवतो. जर तुम्ही करू शकत असाल तर तुम्ही करा. हे तुम्हाला मी सांगितलंच आहे वर्क एनर्जी प्रिन्सिपल काय आहे ते. काय करताय?
सॉल्व करून द्या.
हा ठीक आहे. त्याला एवढा वेळ लावत जाऊ नका की सांगत जाऊ मला पटकन सॉल्व करून द्या. So I will solve it here only, because on the next page you may get confused. So now here what I will say now, या व्हॅल्यू लक्षात ठेवा बरं का, F1 च्या F1 ची व्हॅल्यू 75 आहे आणि R1 ची 250 आहे. हे लागतील व्हॅल्यू, हे आहे 250 आणि हे F1 किती आहे 75. Okay, now consider the free body diagram of this block. Okay, block 1. Here we can write consider FBD of block 1. Now if I consider the free body diagram of block 1, this is the first block. Here it is the centroid. The weight is acting 250 Newton. Normal reaction R1 is again 250 Newton. Then the force in the string, this force, this value is already calculated. Okay, what is the value of this force in the string? It is 1383.36 Newton. This is the force in the string. Now the frictional force is in the opposite direction to that of the motion. So motion left side ला, so frictional force इकडे येणार आहे. So the value of frictional force is 75 kilonewton, and this is the direction of the motion. Motion is in this direction. This is the direction of motion, or you can say displacement. Okay, and now it is cut over here. So here we can show T is the tension in the string. This is the T is the tension in the string. Okay. And हे forces नेहमी आपण centroid पासूनच दाखवत असतो. So T is the tension in the string, and this value we need to calculate. Okay. All these forces we should consider for a single block. Now what I will do for a single block, I will apply work energy principle again. Okay. Now for this single block only. So this. A work energy principle for single block, summation F into S is equal to half M V square minus U square, because there is only one block. Now for this single block only, we are considering FBD of block 1 only for first block. So summation F. So now this is the direction of motion, so same is the direction of displacement. So this force is positive, 1383.36 is the positive force. Minus tension in the string is T, which is in the opposite direction. Displacement horizontal आहे म्हणून horizontal forces येणार इथं. Okay, displacement vertical असते तर vertical forces घेतले असते इथं, horizontal घेतले नसते. So displacement आपली या डायरेक्शन ला, horizontal डायरेक्शन ला, म्हणून हे दोन horizontal forces कॅल्क्युलेशन मध्ये आले. त्याच्यात पण जो फोर्स हा डिस्प्लेसमेंटच्या बाजूला आहे तो तुम्ही पॉझिटिव्ह घेणार. जो फोर्स हा डिस्प्लेसमेंटच्या अपोजिट डायरेक्शनला आहे तो तुम्ही काय घेणार, निगेटिव्ह घेणार. Then again minus T again. Here this frictional force, this is also opposite direction to the displacement, minus 75 into S. ह्याची डिस्प्लेसमेंट किती झाली आहे या फोर्स मुळे ऑलरेडी सांगितले त्यांनी. व्हॉट इज द व्हॅल्यू ऑफ S? 4.5 मीटर. So into 4.5, which is equal to, here it is half, M is the mass, so 250. What is the mass? We have already calculated. What is the mass? किती आहे? 250. Mass is 25.48. एकच ब्लॉक है ना, 250 न्यूटन into v square. What is the final velocity? Final velocity is 3. Initial velocity is 0. So final velocity is 3. 3 square minus 0 square. Now if you solve this, you will get the value of T, tension in the string. Okay, you will get the value of T, or you can call this as a T1 also. Okay, you can call this as T1 also. Now solve this. I don't have the answer for this. This is the extra part I have taken. You solve this and let me know the answer. Okay. Okay, now the time is 3:35. So at 3:37, we will start the further bit. Okay, take a break of 2 minutes. Don't go so far. So now 3:35 is there. At 3:37, drink the water only, and then 3:37 we will continue. Okay. And up till now, calculate the answer. What is the value of T? You give me the answer. What is the answer? One two eight 2.88. Okay, good. So 1282.88 Newton. So this is the tension in the string. So these are the all problems about the work energy principle. Okay, only these types of problems are there. There is nothing else will be asked to you. हेच प्रॉब्लेम तुमच्या सिलेबसला आहे आणि एवढंच आहे वर्क एनर्जी प्रिन्सिपल तुम्हाला. एक तर बॉडी हॉरिझॉन्टल प्लेनवर असेल किंवा बॉडी इन्क्लाइन प्लेनवर असेल. एक तर एक ब्लॉक दिला असेल किंवा दोन ब्लॉक दिले असतील. तेवढंच आहे तुम्हाला. तीन सुद्धा ब्लॉक रेअरली पडतील एखाद्या वेळेस. तीन ब्लॉकचा पण प्रॉब्लेम तुम्हाला पडणार नाही. बट आय हॅव टेकन इट पर्पजफुली सो दॅट इफ यू नो हाऊ टू सॉल्व इट फॉर 3 blocks, for 2 blocks you can easily solve. Okay, दोन terms येणार for 2 blocks. So this is all about this work energy principle. Now only 2 bits are remaining, that is impulse momentum and then collision. These two are also very easy. See, in this work energy principle, what is our formula? Summation F into S. म्हणजे work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy. This is our work energy principle. Now what is impulse momentum? So impulse momentum is impulse is equal to change in momentum. Okay, impulse is equal to change in momentum. That is the theorem of impulse momentum. So we will see first what is impulse and momentum, and then we will take the numericals. So here impulse momentum. You write it down with me every time. So impulse momentum. So first impulse. Impulse. So impulse is, what is impulse? It is the product of force and time. Work done मध्ये काय होतं? Work done is the product of force and displacement. Work done ला काय घेतो आपण? Work done is the product of force and displacement. आता इथे impulse आहे. Impulse म्हणजे काय? Impulse is the product of force and time. Force and time. Okay. So here I can write impulse is equal to force is F into time is F into T. Okay. The unit of impulse is force unit काय असते? Newton. Time unit काय असते? Second. So the unit of impulse is Newton second or kilonewton second. असे होऊ शकतात etc. Okay. Normally Newton second is used. The SI unit of force Newton normally it is taken, and for time second is normally taken. Although you can measure it in minute, in hours also, but generally second is taken. So now, what is the impulse momentum? That we will see now. Impulse momentum, this upper part. What is impulse momentum? Here, according to Newton's second law, F is equal to ma. Okay, F is equal to ma. Okay, but we know that V is equal to what? V is equal to U plus AT. Therefore, A is equal to, it is V minus U divided by T. This already we have seen. A is equal to V minus U by T. So this value of A, if you put over here, then what you will get? Instead of this A, if you put this value of A, then on that side it is F is equal to M into, instead of A, it is V minus U divided by T. Okay. So here F is equal to, if I multiply it inside by M, it is MV minus MU divided by T. MV minus MU divided by T. So if you transfer this T to that side, then it will be F into T is equal to MV minus MU. So in words, if I write this, then it will be this F into T is nothing but, we call this as impulse. This is impulse. MV is what? It is mass into velocity is momentum. Mass into velocity is momentum. Here it is V, so this is final momentum. This is final momentum. Here it is mass into velocity, but U is there. So this is initial momentum. बघा इकडे लक्षात ठेवा फॉर्म्युले बर का. मास इंटू वेलोसिटी म्हटलं तर त्याला म्हणतो आपण मोमेंटम. आणि फोर्स इंटू वेलॉसिटी जर म्हटलं तर त्याला म्हणतो पॉवर. अंडरस्टँड द डिफरन्स. फोर्स इंटू वेलॉसिटी जर केलं तुम्ही, फोर्स इंटू वेलॉसिटी, तर तुम्हाला मिळती पॉवर. जर तुम्ही फोर्स इंटू डिस्प्लेसमेंट केलं तर तुम्हाला मिळतं वर्क डन. ओके. जर तुम्ही मास इंटू वेलॉसिटी केलं, मास इंटू वेलॉसिटी हा प्रोडक्ट घेतला तर तुम्हाला मिळतं मोमेंटम. ओके. आणि जर तुम्ही फोर्सला टाइमनी मल्टिप्लाय केलं, फोर्स इंटू टाइम केलं तर त्याला तर काय मिळतं, इम्पल्स. That is called as impulse. So these very small formulas are there. You should know this. So here impulse, this is impulse, but here you can see mv minus mu means what? Final momentum minus initial momentum. So final momentum minus initial momentum म्हणजेच काय? Change in momentum. So here you can write impulse. What is impulse? So impulse is equal to change in momentum. Impulse is equal to change in momentum. That is your final formula is this one. F into T is equal to change in momentum is final momentum minus initial momentum. It is final momentum minus initial momentum. This is your impulse momentum. This is impulse momentum. Okay. So here how to take plus and minus. So here also F means it is summation F. Huh? Remember this. F means it is summation F. You should consider all the forces which are in that motion, in the direction of the motion. Okay. So here you can see summation F into T. So write down the sign conventions. When to take the force positive and when it will be taken as negative. Sign conventions. Okay. First, if force is in the direction, force is in the direction of motion, then it is positive. Okay. Second, if force is in opposite direction of motion, then it is negative. Okay. Then it is negative. So if the force is in the direction of the motion, then it is positive. If the force is in the opposite direction of the motion, then it is negative. So this is the impulse momentum. Impulse is equal to force into time. So impulse is equal to change in momentum. This is called as impulse momentum law. Impulse momentum law. What is impulse momentum law? Impulse is equal to change in momentum. This is the impulse momentum law. Impulse is equal to change in momentum. That is your impulse momentum law. मगाशी शिकलो वर्क एनर्जी प्रिन्सिपल, आता शिकतोय impulse momentum law. Okay. So now this is very simple. So we will take the numerical on this impulse momentum. That's all. A block of weight, block of weight 1500 Newton is in contact with level plane. So, the coefficient of friction between contact surface, between contact surfaces is 0 is 0.1. So if the block is acted upon by a horizontal force just 1 minute.
सर आवाज येत नाही.
Okay, now we will read the problem. A block of weight 1500 Newton is in a contact with level plane. So plane is level. On the level plane it is resting. The coefficient of friction between the contactors is 0.1. If the block is acted upon by a horizontal force of 300 Newton. So on that block a horizontal force of 300 Newton is acting. Okay. So what time will elapse before the block reaches to the velocity of 16 meter per second starting from rest? So starting from rest means initial velocity is 0. आणि त्याची फायनल व्हेलॉसिटी काय सांगितली 16 मीटर पर सेकंड. मग या रेस्ट पासून 16 मीटर पर सेकंड एवढी व्हेलॉसिटी अचीव्ह करायला त्याला किती टाइम लागेल असं विचारलंय. What time will elapse before the block reaches the velocity of 16 meter per second starting from rest? हा एक पार्ट झाला प्रॉब्लेमचा. हा फर्स्ट पार्ट. ओके, टाइम कॅल्क्युलेट करणे. What is the second part? If the 300 Newton force is removed, मग आता 300 Newton force is removed, then how much longer time the block will move? ओके, म्हणजे किती वेळ ब्लॉक मूव्ह होत राहील. मग कधी ब्लॉक थांबणार जेव्हा फायनल व्हेलॉसिटी काय होईल त्याची 0 होईल. ओके, म्हणजे 0 to 16 मीटर पर सेकंडला किती वेळात जाणार हे काढायचंय आणि 16 मीटर पर सेकंड पासून परत 0 किती कधी होणार हे आपल्याला कॅल्क्युलेट करायचं. ओके, सो बेसिकली नाउ I will draw the diagram for this numerical. So on the next page we will draw the diagram here. Now the block, this is the block. Here is the force of 300 Newton is acted, horizontal force of 300 Newton is acting on this block. Weight of block which is acting through the CG, and this weight of block it is given as 1500. This block is of 1500 Newton. Okay. So we will get the normal reaction also. So here this is the normal reaction. Only single block is there, so I will write here R. 2-3 block असले तर R1, R2, R3 लिहायचं. So what is the direction of the motion? Now force is applied in this direction. Okay, so my direction of motion is this one. This is the direction of motion. या direction ला block जाणार. Okay, so it is started from the rest. So initial velocity of this block is 0 meter per second before the application of the force. So it is at rest. When you apply a force of 300 Newton, it will move. Okay, suppose now this block is here at this position now. At this position. Okay, and now here at this position, its final velocity v is 16 meter per second. 16 meter per second. तर त्यांनी काय विचारलंय की ह्या पॉइंट पासून इथपर्यंत जायला म्हणजे ही व्हेलॉसिटी अचीव्ह करायला ह्याला टाइम किती लागला. ह्याला टाइम किती लागला हे आपल्याला कॅल्क्युलेट करायचं इन फर्स्ट फेज. So to solve this, what we will do now, we will calculate first what is the frictional force. So see, this is the direction of the motion, then obviously your frictional force will be in the opposite direction to the motion. So this is my frictional force F. So if I apply summation Fy equal to 0, summation Fy equal to 0, then what I will get? It is R minus 1500 is equal to 0. Therefore, R is equal to what? 1500 Newton. Now we want frictional force. So frictional force F is equal to mu into R. So F is equal to the value of mu is 0.1 into R. What is the value of R? R is the normal reaction 1500. Therefore, what is the value of F? F is 150 Newton. So the force is 150 Newton. Now we want to calculate the time. Okay. So displacement here they have not asked us for the displacement. Displacement दिली असती तर आपण वर्क एनर्जी प्रिन्सिपल ने सोडवला असतं. डिस्प्लेसमेंट विचारली असती तर. आता इथे टाइम विचारलाय. सो इफ दे आस्क यू द टाइम देन यूज इम्पल्स मोमेंटम. ओके, त्यांनी सांगितलं इम्पल्स मोमेंटम मी सोडवा. So by using impulse momentum law or principle, impulse momentum, you can say it as a law or principle also. What you want, you can say it. Impulse momentum principle. What this principle says that impulse is equal to, impulse means what? Summation F into T is equal to change in momentum. Change in momentum. This is the law. Impulse is equal to, I will write here in the words only. Impulse. The law says that impulse is equal to change in momentum. So now what is impulse then? Impulse is summation f into t. What is change in momentum? Change in momentum, it is single block is there. So change in momentum is mv minus mu. Okay. If you take m common, then summation f into t is equal to what? It is m v minus u. This is for single block. Okay. दोन ब्लॉक असते तर m1 v1 u1 प्लस m2 v2 u2 हे टर्म रिपीट होणार. तीन ब्लॉक असले तर तीन वेळेला. Okay. But generally for a single block the problem is asked on impulse momentum. So now this is the equation of impulse momentum. Now we will put the values summation f. So this is the direction of the motion. The forces which are in the direction of the motion are positive. So 300 Newton. This is in the direction of the motion. So 300. F is the opposite direction to the motion. It is 150. So minus 150. Okay. फोर्सेस हे दोनच आहेत या डायरेक्शनला, डिस्प्लेसमेंट आणि मोशन इकडेच आहे. त्यामुळे हे दोन फोर्सेस आहेत त्या डायरेक्शन मध्ये. हे दोन फोर्सेस येणार नाहीत कारण डिस्प्लेसमेंट हॉरिझॉन्टल आहे, मोशन हॉरिझॉन्टल आहे. इनटू टाइम. टाइम मला आपल्याला माहित नाही, कॅल्क्युलेट करायचं आहे. टी एज इट इज which is equal to m. M is the mass. So what is the weight now? 1500. So weight is given. W is equal to 1500 Newton. So mass is equal to, it is 1500 divided by 9.81. Therefore, what is the value of mass? So the value of mass will be 152.90 kg. This is the mass. Here I will put the value 152.90. Velocity, what is the final velocity? 16. What is the initial velocity? 0. Now here the only unknown is time. Therefore, if you solve this, you will get the value of t as 16.30 seconds. 16.30 seconds. So it will take a time of 16.30 seconds from 0 to 16 meter per second. जायसाठी त्याला टाइम किती लागेल? 16.3 seconds. ओके. प्रॉब्लेम इथं संपलाय का? नाही. पुढे काय विचारलंय बघा ते. Further they ask you something else. Further what they have asked you? ह्या पहिला पार्ट संपला. Now, if 300 Newton force is removed, म्हणजे हा 300 न्यूटन लावलेला फोर्स आता काढलाय. ओके, म्हणजे इथपर्यंत आला आता इथं आल्यावरती हा जो 300 न्यूटनचा फोर्स होता हा काढून घेतला. तर ह्याची वेलोसिटी परत 0 व्हायला, म्हणजे हे परत थांबायला किती वेळ लागेल म्हणून त्यांनी विचारलं. ओके, म्हणजे आता सेकंड पार्ट मध्ये काय झालं की तुमची इनिशियल वेलोसिटी काय झाली? इनिशियल वेलोसिटी झाली 16 मीटर पर सेकंड. ओके, आणि ते किती वेळानंतर थांबणार आहे म्हटल्यावरती फायनल वेलोसिटी काय झाली? 0 मीटर पर सेकंड. आणि हे 16 चं परत 0 व्हायला किती टाइम लागेल म्हणून त्यांनी विचारले आपल्याला. पहिला टाइम काय विचारला? 0 चं 16 व्हायला किती टाइम लागेल ते आपण कॅल्क्युलेट केला. आता आहे 16 ला, तेव्हा हा 300 न्यूटनचा फोर्स त्यांनी काढून टाकलाय, आणि फोर्स काढून टाकल्यामुळं हा 16 चा परत 0 व्हायला किती वेळ लागेल म्हणून त्यांनी विचारलंय वेलोसिटी. So for that again we will use the impulse moment equation. So what is the equation again? So it is summation f into t is equal to m v minus u. M v minus u. So summation f. Now the 300 Newton force is not there. 300 Newton force is not there. Only the frictional force will present. 300 चा फोर्स काढून टाकलाय म्हणून सांगितले. So what will remain? It is minus 150 into t. Okay, which is equal to m. M is what? Mass. 152.90. What is the velocity? Final velocity. Final किती व्हायला पाहिजे आता? 16 पासून परत 0 व्हायला पाहिजे. म्हणजे फायनल वेलोसिटी काय झाली? 0 मायनस. आणि आता सध्याला वेलोसिटी किती आहे? 16. So 16 is your initial velocity for second case. This is your case number 1. This is your case number 2. Now again, if you solve this, you will get T is equal to answer. T is equal to again 16.30 seconds. Again, the answer is same. T is equal to 16.30 seconds. म्हणजे ह्या ब्लॉकला ह्याचा अर्थ काय की या ब्लॉकला 0 पासून 16 मीटर पर सेकंद एवढी वेलोसिटी गेन करायला टाइम किती लागतोय 16.3 सेकंद. आणि नंतर जर हा अप्लाइड फोर्स काढून टाकला तर 16 मीटर पर सेकंद वेलोसिटी पासून परत 0 व्हायला पुढे किती टाइम लागतोय 16.3 सेकंद अगेन. दिस इज द मीनिंग ऑफ दिस न्यूमेरिकल and meaning of this problem. Is it clear?
Yes, sir.
समजताय ना?
Yes, sir.
So this is the problem on impulse momentum. One more problem. So this is the problem on level plane. Okay, so here also two varieties are there. Once the block is on the level plane and another thing is block on the inclined plane. Likewise the work energy principle. वर्क एनर्जी प्रिन्सिपल मध्ये कसं लेवल प्लेन वरती आपण केलं आणि इन्क्लाइन प्लेन वरती केलं कॅल्क्युलेट. तसंच सेम आहे ह्याला सुद्धा. पहिल्यांदा लेवल प्लेनचा न्यूमेरिकल आता घेतलंय, आता एक इन्क्लाइन प्लेनचा. ओके, ओनली दीज टू टाइप्स ऑफ व्हरायटीज आर देयर. So the time is 4. So shall we continue? कंटिन्यू करायचं का?
नको सर.
सर 5 ला टेस्ट आहे.
टेस्ट आहे का? ओके
Yes, sir.
ओके. एकच प्रॉब्लेम होता है, संपला असतं इक्वल्स मोमेंटम. ठीक आहे, उद्याच्या लेक्चरला घेऊ. झालं आता इम्पल्स मोमेंटम आणि कोलिजन हे दोन पार्ट झाले की तुमचं वर्क पॉवर एनर्जी संपतंय. आणि शेवटचा जो युनिट आहे तुमचा, in that unit only definition is there. It will require hardly half an hour to tell you the definitions. There is no numerical in the last unit, only theoretical part is there. 5-6 definitions are there, that's it. Okay.
सर
सर
सगळ्या टॉपिक वरती असाइनमेंटचे 10 क्वेश्चन देतात का?
हा 10 क्वेश्चन दिलेले आहेत. मग
सर असाइनमेंट सबमिशन लिंक अपलोड करायची.
हा मी टाकू आज टीचिंग डायरी मध्ये असाइनमेंट सबमिशन लिंक तुम्हाला टाकतो.
ओके.
Okay, ठीक. So now give me the attendance, just a moment. Today is 23 or 24?
24.
Today date is 23 or 24?
24.
Okay, give the attendance. Just 1 minute. Roll number 1,
Present.
2,
Present, sir.
3,
Present, sir.
4. Roll number 4, 5,
Present, sir.
6, 7,
Present, sir.
8,
Present, sir.
9, 10,
Present, sir.
11, 12, 13,
Present, sir.
14, 15,
Present, sir.
16,
Present.
17,
Present, sir.
18, 19, 20,
Present, sir.
21,
Present, sir.
22.
Present, sir.
हा हा लेक्चर चालू आहे. अजून 5 वाजेपर्यंत 5 वाजे हा कंटिन्यू आहे माझं लेक्चर एक्स्ट्रा परत 24 25 or 22
Present, sir.
23
Present, sir.
24
Present, sir.
25
Present, sir.
26
Present, sir.
27
Present, sir.
28
Present.
29 30 31 32
Present, sir.
33
Present, sir.
24 35
Present, sir.
36 37
Present, sir.
38 present. Okay, 39
Present.
40 41
Sir.
42 43 44
Present, sir.
45
Present, sir.
46 47
Present, sir.
48 49
Present, sir.
50
Present, sir.
51 52 53 54
Present, sir.
55 56 57 58 59
Present, sir.
60
Present.
61
Present.
okay, so absent numbers are on your screen. If anybody from this number is present, then you can tell me.
Roll number 40. Present, sir.
कुठे तुमचा absent मध्ये नंबरच नाही 36 नंतर 42 आहे ना इथं see the numbers I have shared the screen with you. These roll numbers whatever they are on the screen, those are absent numbers. So if your roll number is there in this absent list and you are present, then let me know. First see the numbers. Is it okay? आले सगळ्यांचा attendance?
Yes, sir.
Okay. So now today we will stop over here. In the next lecture we will cover the further part.